Good day, everyone. We are a BitLock Bros team, and today we're excited to present our project, CryptoSeal, a cryptography converter developed for our CSOC 329 applied cryptography. CryptoSeal is a secure, web-based toolkit that enables users to encrypt and decrypt and hash both text and files using modern cryptographic methods. Our introduction and objectives is to demonstrate cryptography in action. Our objectives are implement three symmetric and two asymmetric encryption algorithm and provide a for hashing function and integrate user roles and CryptoSeal include features such encrypt and decrypt hash text and files. User interaction is streamlined with an intuitive flowchart guiding users through the tool's functionalities and enhancing their experience while using CryptoSeal. Our application uses Flask for backend and um, SQL are for database, but we didn't implement for now for efficient and secure data storage. On front end naman, we use HTML, CSS, JS to create responsive user interface, complemented by sidebar UI for easy navigation. It also designed to have persistent inputs using Ajax. Our tech used cryptography and hashlib. In encryption algorithms, we use AEC or
Yes.
advanced encryption standard for standard encryption and and triple DES is for included educational comparison, encrypts data 3 times using DES to improve security over the original DES. And Shasha 20 fast and modern for efficiency. And asymmetric encryption, we use RSA to widely use for secure communication and ECC, elliptic curve cryptography, a more efficient alternative ideal for mobile and low power devices. And for hashing function, we implemented SHA-256, the industry standard, and SHA-5, SHA-512, a stronger hash for enhanced strength, and MD5 and SHA-1 included primarily for educational purposes due to known vulnerabilities. And the key features, CryptoSeal provide better solution for encryption and decryption, ensuring data remains secure and confidential throughout its life cycle. The web-based application features a sidebar and following buttons is dashboard, symmetric, asymmetric, and hashing. And user roles and access control are implemented, enabling different permission for administrators and user to enhance security and usability. Now it's time for demo, and also you can access by going to the PythonAnywhere link we provided, and our team names is Mr. Bata Giancarlo and Papa Nico Tagumleo and Me, Kalingasyon Almira. Thank you.
Hi,
It's
so
time.
good day. Today I'd be demonstrating let's say, the application that we created during the time allotted to create it. So we're going to go to the link. So our application is hosted in PythonAnywhere. So you can access it anytime, anywhere. And so here our dashboard, which is a bit incomplete for now. So we're in the process of enhancing the main phase of our application, but rest assured the encryption, decryption, and the hashing functionalities are all working. And so that's what I'm going to be demonstrating today. So first of all, we're gonna go to the symmetric. So here in symmetric, we're gonna offer you three encryption algorithms and two action or two modes. I mean two actions, which allows you to either encrypt or decrypt data, and a mode of use. So if the input is a text or a file. So as we can see, uh, we can select an algorithm, let's say AES, and let's encrypt a data using text. So here we're gonna come up with an encryption or decryption key. So in symmetric encryption, there's only one key, so it is both used in encryption and decryption. Say, let's select an arbitrary key here, and we're gonna input a text. Um, Actually, we can just put anything in here, right? So here, we're gonna encrypt the text. So the encryption of AES and of this text is this string here. So we're gonna copy this to verify if this thing is the or it if it's gonna be decrypted in the same way. So we're gonna paste that, and it's in decrypt mode, by the way. So here, if we press process, it's supposed to bring us back the input that we entered here a while ago. So same, we're gonna have to do the same operation on these two other algorithms. So I'm just gonna do it fast. If, let's say it's hello. We're gonna encrypt that with the same key. So this is the encryption of the triple des or triple data encryption. We're gonna copy that and put that here in the text and put it in decrypt mode. So after we process it, hopefully we get hello. So now we'll go to Chacha 20. Chacha 20, we're gonna do the same thing. We're gonna do hello and reprocess this thing. So here we copy this, we put this in the text and change the action to decrypt. So after doing that, hopefully we get back our text that we entered. Hello. So I'm just gonna put use the file mode in one example. So here we're gonna have AES in encrypt mode, and this time we're gonna choose file. So here the if we choose file, the form changes to accommodate the change that we made. So here we're gonna choose a file. Let's say anything from my computer, I guess. Here. Right. So I've uploaded a PDF. So I'm gonna use a this key to encrypt this file using AES. So it's gonna take a while. And what it returns is not an output text, but rather an output file. So here we can see, no, it's not here yet. I guess yes, there it is. Mira, can you see?
Yes,
So
I
here
did.
we have the encrypted PDF that
Encrypted
I entered a while
PDF.
ago. So
Yes.
if we save this and open it, we're not gonna be able to open it because it's encrypted. And it doesn't make any sense as a PDF actually. So to reverse that, we're gonna choose decrypt and upload that file that we downloaded earlier, the encrypted N331 I01 PDF. Okay. So using the same key,
Um,
we're gonna process this thing and it's gonna take a while because it's gonna be a file and hopefully
Hopefully.
we receive a decrypted PDF. So it's taking a bit longer. Yes, there it is. So we just save this and we're gonna open this. And there it is. It's a decrypted file of what we did earlier. And moving on, we're now gonna proceed to asymmetric encryption. So here in asymmetric encryption, we have two algorithms. So RSA and ECC. So here we're gonna select RSA first. So here in asymmetric key cryptography, we have several operations. So we have key generation, encryption, and decryption. So here in key generation, we're just gonna choose an algorithm and generate a key. So here in the text areas, we have two panels where it shows the public key and the private key. The private key is a bit longer than the public key. So here, after generating, we can go to encryption. So here, same algorithm, RSA, we're gonna encrypt a message. So say it's hello. Here, prompted with public key PM. So where do we get that? So we can get that here by copying this public key here. So as you can see, the information here is persistent because you're not gonna be able to, for example, you generated a key. If it's not persistent, it's gonna be lost after you generate it or you refresh it or you made another request to the server. So here we made sure the data is persistent. So even if you switch context here, it's still there. Unless of course you generated a new key. So here, hello, and I'm gonna paste the public key and I'm gonna encrypt the message. Here, the result outputted a hex value or hex string, and we're gonna copy that. Up, moving on, so we're gonna move to decryption using same algorithm again, RSA. We're gonna enter the ciphertext in hexadecimal, and here we're prompted with a private key. So where do we get that? In the key generation. So as you can notice, these keys are pairs actually. So if the if you use a different private key for the encryption of a public key, it's not gonna match up and you're gonna get a mess. So you're gonna copy this private key here, move into the decryption and paste it there. Right. So we're gonna decrypt the ciphertext here. and hopefully we get hello, and we did. So moving on, we can try another algorithm, ECC. We're gonna generate key. Here, ECC, it uses few, or it uses shorter keys, or generate few shorter keys for the same performance or same security as RSA by using a intelligent, or say, genius algorithm here. So here, ECC is a stream cipher, I guess, or I don't remember clearly. So here we're gonna copy the public key, and we're gonna move to encryption. So yeah, the algorithm stays ECC. We're gonna paste the public key here and encrypt the message. So unlike the RSA, ECC actually returns a couple of values. So it returns a ciphertext, an ephemeral pub, which is quite long, a nonce, and a tag. So we need all this data here. So that's why I returned a JSON, that so that we can access all of this data at once. So we're gonna copy the result and move to the decryption. So as you can see, the selection of algorithm changed the form. We're gonna paste the what we copied earlier there, or here we can copy it here as well and paste it there. The private key is a bit different because that's what we used earlier. So we're gonna replace that with this here. So hopefully we get the message back. So we're gonna press decrypt, and there we go. So we got hello back. And moving on, we're gonna proceed to hashing. So as you can see, we have several algorithms for hashing as well. MD5, SHA-1, SHA-256, and SHA-512. So first off, the MD5. So MD5 is an old hashing algorithm that has been deprecated because of its insecure nature, because of the improving nature of computers. So here we have two modes, which is text and file. So it's similar with symmetric encryption earlier that I showed you, MD5. We're gonna select text for now, and let's say hello. So hello will generate a hash if we press this using MD5 algorithm. So this thing is the hash of MD5. Unlike encryption and decryption, hashing is a one-way function. So there's no way we can use the hash to get back to the original text. So hashing is used for data verification. So for example, a password is compared against a hash you by hashing the password as well. So if the hash match, it's the same password. How it works is that any text will generate the same hash using the same algorithm. Moving on, the SHA one, we're gonna hash the hello as well. As we can notice it's different length from from MD5 because it uses different algorithm. Also in SHA-256, hashing the text hello, we're gonna get a longer hash as well. That's because it's the industry standard is more secure than SHA-1 and MD5. And lastly, the SHA-512, we're gonna hash the text hello as well. And we got a longer hash digest. So we have another mode here, right? So we have file mode. We're gonna hash a file. So here, if we hash files like this can be used as verification if a file along a network remain unchanged. So if the hash of the intent, the original data or the original file is different from the hash of the file that got to you, it most likely got tampered along the network. So here, if we hash the file, it's taking a bit of time because it's quite large, I guess. And so we wait. Or maybe I should have used a shorter or smaller file. So here we got the hash. It's the same size of any hash because or I mean of any text because that's how hashes work. Hashes or hash digest are fixed size depending on their algorithm. So so far that's the algorithms and modes that we have created or implemented. So symmetric key encryption uses AES, 3DES, and ChaCha20. Meanwhile, the asymmetric key and cryptography uses RSA and ECC. And lastly, the hashing algorithms that we have consisted of MD5, SHA-1, SHA-256, and SHA-512. So with that ends the demonstration of our cryptographic application, which is CryptoSeal. And so thank you for listening and goodbye.